All right. So in our last class, I had gone over with you the different properties that we see of our halogens, right? Now we have went over some of the properties, like I told you, of halogens. Now we are slowly going to go over some of the important reactions as well as some of the important properties that are related to your halogens. Okay, so when we are talking about our halogens of course are your group 7 compounds, and they include your chlorine, bromine, iodine, all of that. And I went over with you all the colors as well, that the color gets darker, the state changes, all those properties we have gone over in our last class. So when we talk about all those properties, right? There's one property that I told you that is really, really important when it comes to halogens. And that was reactivity. Now, please remember this. As we go down the group, the reactivity decreases. Now, this is opposite to what we had studied for group 2. Okay. In group 2 and group 1, I had told you reactivity increases as we go down the group. In group 7, reactivity decreases as we go down the group. So they are both opposites to each other. So please, whenever you're answering exam questions, pay attention to exactly what they're asking you. Now, why is it that reactivity decreases down the group? Let's talk about that. Reactivity decreases down the group because as we go down the group, the number of shells increase. As the number of shells are going to increase, so the outermost shell will get further and further away from the nucleus. Right? Now, what is going to happen? You will, so far, if you guys look at my answer, you will notice that this is exactly similar to what I had told you guys for group 2 as well. I told you the same logic for group 2, that that as you go down the group, the number of shells increase and the outermost shell gets further away from the nucleus. So why is there a difference between the reactivity of group 7 and group 1? The difference comes due to the fact that group 7 elements make negative ions. It makes negative ion, right? Group 7 elements make negative ion, which means that to make negative ions, they need to lose electrons. So as the outermost shell will get further and further away from the nucleus, the harder it will be to, I'm so sorry, I said lose electron, gain electrons. The harder it will be for it to gain electrons. Harder to gain electrons as we go down the group. So it becomes harder and harder for them to gain those electrons to make a negative ion as we go down the group. So this is why reactivity decreases. What does this mean? This means fluorine is most reactive. Once. Just give me 1 second, guys. I'm just coming back. So, all right. So that means that fluorine is going to be the most reactive. Then we have chlorine. Then we have bromine. Then we have iodine. Now, after iodine, we have astatine. Okay. Astatine, just like if you remember in group 2, I taught you guys about francium. Francium was like right at the bottom, right? So francium was also francium, I told you guys, was also found very rarely, and it was radioactive material. Astatine is also a radioactive material, and it is also found very, very rarely. Now, so when you talk about your reactivity, so you can see reactivity decreases down the group, which brings us to what? Which brings us to our displacement reactions. What are displacement reactions? Displacement reactions for the halogens is quite similar to what we had done for our metals as well, right? So what is going to happen? What is going to happen is this, that more reactive halogen can displace a less reactive halogen from its compound. So what does this actually mean, right? Let's see. What this means is this, that let's say I have potassium chloride and I react potassium chloride with fluorine. Since fluorine is more reactive than chlorine, it can displace chlorine from the compound and give us potassium fluoride plus chlorine gas. What are going to be our observations? We are going to observe a pale green gas will form. Now, in this reaction, you guys are going to notice that potassium, not only does the state of potassium not change, the charge of potassium also does not change, right? You guys can clearly see over here that the state and charge of potassium does not change, right? Now, chlorine goes from -1 to 0. Fluorine goes from 0 to -1, right? Chlorine F2 is a molecule, so it will have a charge of 0. Cl2 is also a molecule, so it will also have a charge of 0. Molecules and elements in atoms always have a charge of 0. So you can see fluorine is losing electrons, while chlorine is gaining electrons. So sorry, fluorine is gaining electrons. I said it the other way around. Fluorine is gaining electrons, so fluorine is being reduced. Chlorine is losing electrons, so chlorine is going to be oxidized. If I ask you guys to write down the ionic equation, so in ionic equations, what do? We write down the equation as it is, but we remove any spectator ions. Okay, so over here, for example, potassium. Potassium would be considered a spectator ion because neither the charge is changing nor the state is changing. Okay, the charge and state both are the same. Physical state as well as the charge is the same. So this is known as a spectator ion. Whenever you're writing down an ionic equation, first write down the charges and the state. Then identify your spectator ion. So potassium is a spectator ion. So remove the spectator ion and copy the equation as it is. Okay, so I will not write down potassium. I will write down chlorine, chloride ion plus fluorine gives us fluoride ion plus chlorine gas. Okay, And in this, you can clearly see that chlorine is being oxidized and fluorine is being reduced. So this is an example of your redox reaction. Now, what if we so for example, one second. So you can see that this is what the ionic equation is going to look like. And you should be able to, when given in the exam, make the reaction for all of the halogens like this. Okay. So for example, I have chlorine gas and I have potassium bromide, right? So chlorine is more reactive than bromine. So chlorine will displace bromine from its compound and we will get potassium chloride and bromine, right? This, what is going to be your observation? You are going to observe that your colorless solution, potassium bromide is colorless. The colorless solution is going to become orange. Bromine, when it is in a solution form, it tends to have a orange color, right? Then what if we do the reaction between our bromine and potassium iodide? So once again, bromine is more reactive than iodine. It can displace it from its compound to give us potassium bromide plus iodine. Okay. And this iodine, what are you guys going to observe? Your observations are going to include that your colorless solution is going to just one second. Our colorless solution is going to give you what? A brown solution. Iodine makes a brown solution. When iodine is in a brown solution form, it has a brown color. If iodine is in the form of a solid, then it would have a gray color. And if it's in the form of a vapor, we would have a purple color. So this is what your displacement reactions are all about. And if you do the opposite, if you take iodine and you react it with potassium bromide, there will be no reaction. Why? Because iodine is less reactive than bromine. So it cannot displace it from the compound. Now, this is one of the important reactions of this chapter that you have to know. Now, along with all of these, like all of this, there are a few more reactions that we have to go over. One of the reactions that we have to talk over is the formation of hydrogen halides. So, for example, hydrogen can react with chlorine to give you hydrogen chloride gas. Gas, please remember, this is a gas. Now, you can take this hydrogen chloride gas and you can dissolve it in water to make hydrochloric acid. Now, this we can do with all of the halides. Every single halide, we can go ahead and do that. This is normally the only acid we have studied about is hydrochloric acid. But believe me, you can take hydrogen and you can react it with bromine. You would get hydrobromic gas. This is hydrochloric gas or hydrogen chloride. This is hydrogen bromide. And if you take this hydrogen bromide and you dissolve it in water, you will get once again an acid. And this acid is known as hydrobromic acid, and it's quite a strong acid actually. We only study about hydrochloric acid, but now we can see that there are other acids as well related to halogen. Similarly, your hydrogen can react with iodine to give you hydrogen iodide. And this hydrogen iodide can also dissolve in water to give you hydroiodic acid. Right? So this is the reactions that we see with our halogens that are really, really important, and I really wanted to go over them with you. Now, when we are talking about our halogens, right? So we can see that you guys, so the two properties to understand over here. Property number one is that they will react with hydrogen to make hydrogen halide. Okay. So halogens can react with hydrogen to make hydrogen halide. Right? And if you take this hydrogen halide and you dissolve it in water, you can form a strong acid. If you take this hydrogen halide and you dissolve it in water, you can make a strong acid. So this is also a property of halogens. Then, when you are going to talk about it, please keep in mind that the halogens can also react directly with metals to form salts. What does that mean? That I can take sodium and react it with chlorine to make sodium chloride. Right? Like they can also directly react with your with metals to form your ionic compounds. They can directly react with metals to form your compounds, right? Now, when we are going to talk about it, so when we're going to go ahead and talk about it, so we can see these reactions, especially with chlorine and fluorine. These reactions are very common. With bromine and iodine, you might not see them that much, but chlorine and fluorine can easily give you these reactions. One of the common reactions that I can tell you guys about is the reaction between aluminium and chlorine, right? Because chlorine and fluorine are very reactive. So they can easily react with the metal to give you an ionic compound. So aluminium, for example, can react with chlorine to form aluminium chloride, right? This is actually a very common reaction that is done. And in this particular case, we can heat aluminium with chlorine, and we can actually form aluminium chloride. Okay. Now, when you talk about chlorine, one more point that I want to add. A lot of your fluorine, chlorine, iodine, bromine, they can also be dissolved in water directly. So you can directly take chlorine and dissolve it in water. Now, all of these compounds, all halogens are acidic. Halogens are acidic. You guys can see that even when you dissolve the halides in water, you're getting an acid, right? So when chlorine directly dissolves in water, it makes hydrochloric acid and a new type of acid, HClO. HClO is hydrochlorous acid. HCl is hydrochloric acid. Hydrochlorous acid and hydrochloric acid are formed. This is why we can use chlorine for disinfection of water. Okay, like as you know that you can use chlorine for disinfection of water, right? Like for sterilizing water in your pool, in your swimming water, in your drinking water, you can add chlorine. This is why, because when it dissolves in water, it produces hydrochloric and hydrochlorous acid, and that hydrochloric and hydrochlorous acid is going to that hydrochlorous or hydrochloric acid is going to actually kill the bacteria that are present over there. Does anybody have any confusion so far? Any part that's not making sense, or any questions regarding anything?
No.
Hajra, Shreya, I hope everything is all clear.
Yes.
Yeah.
Okay. Now, there's one important thing that we have to go over, and that is the test for our uh halides. Okay. So now I know the Viraj and Shai went over these chemical tests with you before as well, but I'm revising the test for halides because they are very much relevant to this topic. So when you talk about the test for halides, what are halides? Halides are the negative ions of halogens. So in the test for halides, the test that we do is this: add nitric acid, and then add silver nitrate. Why do we add nitric acid? The examiners will ask you. The reason you add nitric acid is to remove any carbonate ions, right? If you are performing, if I give you guys a solution and I say to you guys, I think there might be a halide in this, can you please test it for me? You directly add silver nitrate. Okay. Now, there is a possibility that there are carbonate ions in my sample. You guys don't know that. You guys don't know if my sample is pure. You guys don't know what's inside my sample. You just have to show me whether halide ions are there or not. So that means you need to remove any other ions that could be there. So especially carbonate ions, we have to be careful about. Why? Because majority of carbonate ions will give you a precipitate. So if carbonate ions are present, let's say that in my sample there were carbonate ions, but there were no halides. You got a white precipitate. You come to me and you say, Miss, we got a white precipitate, halides are present. But your result is incorrect because your result was due to carbonate ions, right? Because carbonate ions, majority of the time, it will give you some kind of precipitate. So to remove the carbonate ions, first we will add the nitric acid. The nitric acid will react with the carbonate and, and turn it into carbon dioxide. Then you add silver nitrate. Okay. Now, what happens that silver nitrate will react with your halides. If there is any halide ion present, it will react with it to give you silver halide. Right? This is the main thing. Silver will react with your halide to give you silver halide. Silver will react with, for example, chloride to give you silver chloride. Right? Similarly, silver ions will also react with bromide ions to give you silver bromide. Your silver ions can also react with iodide ions to give you silver iodide. Silver bromide, silver chloride, silver iodide. These are all insoluble salts if you guys remember the topic of acids, bases, and salts. These are all insoluble salts. So when the salt is insoluble, it gives you a precipitate. So silver is silver chloride. If chloride ions are present, I will see a white precipitate. If bromide ions are present, I will get a cream precipitate. So sort of a bit of yellowish, whitish precipitate. And if silver ions are present, if iodine ions are present, I will see a yellow precipitate. And this is how you can test for your uh, for your this is how you can test for your negative, for especially for your negative ions, especially for your halide ions. Now, obviously, if I'm talking about the test for ions, let me just in case also mention for you guys the test for chlorine gas. If you guys are ever asked to test for chlorine gas, please remember that we use a litmus paper. Now, the observation is slightly different than the observation for other gases. It bleaches litmus paper. It doesn't change the color. It literally bleaches it, meaning that it makes it white. It will literally make it white. It literally bleaches it. Okay. So this is what we have to know regarding our topic of periodic table. Does anybody have any confusion or any part that was not clear? Virat, Shreya, Halsha, I hope everything is all clear.
Yeah.
Yes. Okay, so that's it. We're now done with our topic of periodic tables. So in periodic table, there are three portions of the chapter. One is your obviously introduction of the periodic table. Then you have your group two, group one and group two, and then the third portion is halogens. So let me go ahead and go over a few questions with you guys. 1 second. All right, these are just some small practice questions for us to go over so we can see how to answer questions. This question is about salts. When solutions of salts are mixed together, precipitates sometimes form. The insoluble salt barium carbonate forms a precipitate when solutions of the soluble salts ammonium carbonate and barium chloride react together. When the solutions of, just give me 1 second, hold on. Let me see. 1 second. I wanted to go over this other question. Let me share that one. Right, this one. This question is about halogens. The table gives some information about halogens. Complete the table by predicting the physical state of astatine at room temperature and color of astatine. Can somebody give me what do you guys think will be the physical state?
Solid.
Yeah, it's probably going to be solid, right? I mean, thing is that a lot of these elements like astatine and francium and all, we cannot really know exactly how they are because, like I told you guys, they're highly radioactive. They break down very quickly, and their half life is so small that like we can't study them. So a lot of this is prediction. But yes, looking at the trend, we can say it will be solid. And what do you guys think should be the color?
Gray.
Yes, correct. Okay. Now, a student investigates the reactivity of some halogens. She uses these solutions of halogens and their halides. She has bromine, chlorine, and iodine, and she has sodium bromide, sodium chloride, and sodium iodide. She adds each halogen solution to each halide solution. The table shows the results. Explain how these results show the order of reactivity of bromine, chlorine, and iodine.
Where it goes from less reactive to more reactive, yeah?
Sorry, Virat, what did you say?
Does it go from less reactive to more reactive?
But you have to also give an explanation. So it's for 3 marks. So you need to, if possible, please type it out in the chat with an explanation. Why do you think it goes from less reactive to more reactive, if that's what you're saying? You have to also give a reasoning behind your answer. Since you know what, write it down in the chat so that everybody gets a chance to answer it. Are you guys done yet with the answer? All right, I got the answer from Hajra and Shreya. Viraj, I'm just waiting on yours. The order would be chlorine, bromine, iodine, because chlorine would displace bromine and iodine would displace bromine. Um, okay, Hajra, your answer is fine, but you do need to refer a little bit to the table as well. So, for example, you can say that when chlorine reacts with sodium bromide, the reaction occurs. That means chlorine is more reactive than bromine, like this. Okay, when chlorine reacts with sodium iodide, once again the reaction occurs. That means chlorine is more reactive than iodine. So chlorine is the most reactive, right? I know we all know the answer, but we have to use the table to give the answer as well, right? So you have to refer to the table. So you say that chlorine reacts with sodium bromide as well and sodium iodide as well. So it displaces both bromine and iodine, which means that chlorine is the most reactive. Bromine does not displace sodium chloride or does not react with sodium chloride, but it reacts with silver iodide. So bromine is less reactive than chlorine, but more reactive than iodine. And then say iodine does not react with any of the solutions. So that means iodine is the least reactive. Okay, both your answers are correct in terms of theory, but you have to use the table to reinforce your answer or reconfirm your answer. Okay, now the ionic equation for the reaction between bromine and sodium iodide is given to you. Explain why this is a redox reaction. Can somebody explain why this is a redox reaction?
So oxidation and reduction occurs at the same time.
Right. Virat, can you just give a bit more detail as to the oxidation and reduction, like who's getting oxidized, who's getting reduced, and why?
Oh yeah, iodine is losing electrons, so it's getting oxidized, and Br2 is gaining
Mm-hmm.
oxidants, so it's reduction.
Yeah, bromine is reduced and iodine is oxidized. Correct. All right. Okay, everyone. So we'll go ahead and stop it here for today. And we'll take a look at some questions on this in our next class. Okay.